Hi, and welcome back. So last time we talked about the purpose of named subsetting, where we can say assign labels or assign names to each element in our vector, and then say I want to extract the element that corresponds to that name. And we said that this was stronger for reproducibility because the data structure may change over time, or the position of the elements of the data may change over time, but the names are probably going to be a little bit more stable. Um, so that was just a little bit of material on that, and we talked a little bit about how you cannot use negative subsetting with names, at least not yet. We will learn a technique that will allow us to do that later. But for now, whenever you're using names, you can only use positive subsetting, i.e., give me the thing with this name. You can't do give me everything except for the thing that has this name. So now for factors. So earlier I had put in my ID vector that I'm living in Florida, but I moved from Texas. Like my state of origin was Texas. So what if you had given this to people as a free text field for them to type whatever they want in there? Even if you said type the state that you're from, well, you would end up with something like you could end up with a lot of things. Um, you could end up with somebody spelling Florida with an uppercase F or a lowercase f, or they spell like a so we can see where somebody would type in FL, or somebody could type in Florida, and we can confirm that these two are not the same thing. So Florida is not equal to FL. This is going to be false. And even though we understand that Florida and capital F, capital L are talking about the exact same thing, they're both talking about the state of Florida. That does not mean that R is going to understand that that's what we mean. And realistically, that a computer would understand that that's what we mean. Um, so whenever we want to get information from people, but we want that information to have a little bit more structure, particularly for something that could come from a categorical variable. We often want to use something called a factor. Now, a factor you can think about as like a set of options for the user to choose from. And you could say, okay, well, in the medical school, for instance, we only accept doctoral degrees as something of the following. So, a doctor of science, doctor of philosophy, doctor of public health, juris doctor, medical doctor, MBBS, which is for bachelor medicine, bachelor of surgery, doctor of osteopathic medicine, and doctor nurse practitioner. So if those are the doctorates that a medical school will accept as actual doctorates of some kind, either clinical or research doctorates, then you can give people these options and say, okay, in order to get promoted in the organization. So I was working at a hospital some years ago where, in order to get promoted to a certain level in the organization, you had to have an MBA. Didn't matter if you had a PhD, an MD, a whole bunch of other degrees. If you didn't have the MBA, you were not allowed to get promoted up into that field. So you could think about that there are certain privileges in a hospital, or like the overall business organization of a hospital, where you're allowed to have certain roles and responsibilities in that hospital based on the degrees that you have. So in that case, a factor would probably be a good way to design this in R, to say, well, here are the choices that you get to pick from. You have to pick one of these. Well, what about my doctorate of sacred theology? It doesn't really, like, a hospital is probably not going to care about that very much. And we can see here that if I tried to include my doctorate of sacred theology as one of the degrees in this list, it's actually going to spit back NA. Well, why is that? Well, it's going to say, well, you gave me a degree, but it's not one of the degrees that match that belong to my list. So therefore, I don't know what you mean. I don't know what this thing is. Therefore, I'm going to represent it with I don't know. That is, so NA, if you see NA and R, that means I don't know. R does not know what you're talking about. R does not know what that piece of information is. So NA is R's way of saying that my doctoral degree is missing. That is, you've supplied a degree, but it's not one of the options that I have that I'm allowing you to pick. So I don't know what degree you're talking about. I don't know. All right. So now this is a factor. We've said, okay, well, my degree is a factor, and we create factors with this function called factor. Okay. And we have to factors usually supply levels, and that's what tells R that these are the options that you're allowed to have. Now, what's interesting here is factors, if you think about it, if you're only allowing a certain finite number of options, then suddenly, if we go back to our order of complexity of atomic vectors, we had logical, then integer, then numeric, then character. If you say, okay, well, you're allowed to have in this factor, you're only allowed to have, say, 5 different options, then that means that factors actually sit somewhere in between logical and integer. Because integer has an infinitely many number of options from negative infinity to positive infinity of all the counting numbers, and logical only has 2, true or false. We could build factors that have 5 options or 10 options. Well, that's a lot fewer than infinity, but perhaps a lot more than 2. So that's somewhere kind of in the middle. And the reason and why I'm bringing this up is because under the hood, R is actually going to treat factors as integers. So it's going to kind of live in between this world. Now, integers go again from negative infinity all the way up to positive infinity in terms of the counting numbers, but factors don't. Factors are going to have a finite number of categories. And so therefore they will always be represented in terms of complexity less than the integers, because there's countably infinite integers from negative infinity to positive infinity, but there's not infinitely many categories that you're going to have for a factor. So the class of this object is factor, but the type of, i.e., the storage mode, how R stores this information in the computer, is going to be an integer, which is honestly kind of cool because it means that you get to store what would be relatively complex information, like these are all characters, which normally take up a lot of space on a computer. But instead of storing the character on the computer, you store an integer instead, and then like a legend that says, if I see the number 1, 2, 3, 4, if I see the number 4, then I know that that's representing JD or Juris Doctor. So I don't have to store JD on the computer. If there's 50,000 JDs in my system, I don't need to store the character vector JD 50,000 times. I only need to store the integer 4 50,000 times, which is way less complex, way easier for the computer to manage, because integers are a lot easier to deal with. Think about it in terms of complexity. Integers are all the way down here, whereas character information is way up here. Okay, so factors, really cool way to kind of to express moderately complicated pieces of information, but you get 2 benefits. Number one, you're forcing the people to choose one of your options, so you don't end up in this did they mean Florida or did they mean Florida scenarios where the computer has no idea what the person is talking about, but you do. And it also helps store your data in a smaller size on the computer, if you will. Okay, here's a lot of exercises. So I'm going to pause the video here. I want you to work on these exercises. Okay, so you had a few minutes to work on the exercises. I hope you learned something about that from the exercises. Make sure that you discuss what you learned in these exercises with some of the other folks in the class or your partners for your learning experience. So anyway, that's factors. Factors are kind of helpful. They can sometimes be a little bit annoying, but once you get the hang of them, they're very useful. So we introduced earlier this idea of missing values, and that was R's way of saying I don't know. And we said, well, is the THD one of these degrees that could possibly be that are in the list of accepted degrees by the hospital? And it came back NA. So, and that's R saying, I don't know. I don't know what this THD thing means. So that NA is R's way of saying, I don't know. Now, in other languages, like for instance, I think SAS uses a period to say this thing is missing. I've seen certain data dictionaries where all of the data coded as negative 999 is actually a missing value. So I was working with an ecology data set, and they had a count of birds in a particular, like a 2 acre area of woodland or something they had done catch and release surveying on the birds. And for whatever reason, this particular 2 acre or 2 by 2 square acre region of forest, the data was negative 999. And I asked them about it, and they're like, oh, well, in this particular area of the Forest Service, the U.S. Department of the Interior, or whatever it is, because it's a count, everybody knows that you can't have a negative count of something. So they used negative 999 to say that the count was missing, i.e., the instrumentation was wrong, or they didn't make it to the site, or something. And because they're having a physical count of birds, it's impossible to have a negative count of anything. So they used negative 999 to represent missing values. We don't do that. Please don't do that in R. We use NA. Okay. And there's a couple of different kinds of NAs, but I want to talk about, first of all, what NA means. And I want you to go back to this idea of NA meaning R telling you, I don't know. All right. So if you say, is something unknown less than 3? So that's what this is saying, is NA less than 3. Well, I don't know if NA is less than 3 because I don't know what NA is. Again, what is NA times 2? What is I don't know times 2? Well, I don't know because I don't know what NA is. How about this one? NA and true are both NA and true true. Well, if I don't know what NA is, how am I going to know whether or not it is true? Now, this is interesting though. Is NA or true true? Well, I don't know what NA is. I don't know if this is true or false or something else, but I do know that true is true. And or just says, I need at least one of these to be true. And it says, okay, well, I see a true over here. So this is true. Now, this is one that bothers people. Is NA equal to NA? Okay, now here's what I want you to think about this. This is saying, is I don't know equal to I don't know? And you might say, well, yeah, it is. But I'm going to counter and say, I want you to number the hairs on your head. Just tell me how many hairs are on your head. And if you say I don't know, like, okay, that's fine. That's NA. Now go to your partner and number the hairs on their head. Well, you don't know that one either. So is the NA for the hairs on your head equal to the NA for the hairs on their head? Probably not, but you also don't know. It could be that you have the exact same number of hairs on your head. We don't know. We don't know how many hairs you have on your head, so that one's NA. We don't know how many hairs they have on their head, so that one's also NA. But are those two NAs equal to each other? We don't know. We don't know if they're equal to each other or not, because we don't know what the two numbers are. And then this one is also super helpful. This is just to find out if something is missing or not. So is this thing NA? And that is going to be true. Okay. Now, because there are a bunch of different ways that we can have atomic data in R. So remember, we've got logical, integer, numeric, and character. So there's 4 different ways that we can have atomic data. Then that means there's 4 ways that we can have missing data in R. And technically, there's missing complex data, there's missing raw data. But if we're talking about just these 4, there's going to be 4 ways for us to have missing data. And these are the type-specific missing values. So if you see just NA, then R is assuming that it's missing logical, so that it should be either true or false, but it's missing, so it's going to be NA logical. NA underscore integer says, well, I know whatever it is, it's going to be integer information, but I don't know which integer it is. NA underscore real. Now, why in the world this isn't NA underscore numeric or NA underscore double? I don't know, but this is the missing value for double slash real valued vectors. And then NA underscore character, this is missing character information. Now, you're rarely, if ever, going to actually have to type this stuff. Most of the time, just NA by itself will work because R is going to handle the type coercion and type promotion for you. Okay. One last bit. These arithmetically induced quote unquote missing values. Okay. These are not actually missing. And I want you to understand this mathematically. This is not a missing value. Okay. If you try to take the log of -1, this is some value in another mathematical plane that exists outside of the real numbers. And if you divide by 0, you get infinity. Okay. Now, well, you get infinity in R. There's a note on how we shouldn't be dividing by 0 regardless. Please don't do it. Bad things will happen. But anyway, there's different ways that different computers handle division by 0. So just be aware of this. And finally, these are all the missing values for atomic pieces of information. We also have missing values for non-atomic information, and that's null. But we are going to talk about that more in the next lesson, which is the lists and tibbles. So if you remember, we gave an example where we had a matrix with 2 rows and 3 columns, and we assigned column names to that matrix. And then when we looked at the structure of it, it said that the row names were null. So we can go back to this. We can say, okay, so X mat is a matrix, and I'm going to make it integers. So I'm adding the L to make it a matrix of integers, where the number of rows is equal to 2 and the number of columns is equal to 3. And then the call names of xmat are going to be, let's go easy. This is just going to be letters, the first 3 letters. So 1 to 3. And then if I do the structure of xmat, notice I have column names. I have column A, column B, column C, but this doesn't say NA, 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 or NA, or actually it would just be 2 of them because there's 2 rows. So X mat, there's not NAs over here. Well, it's actually because this thing right here, this dimension names, is not atomic information at all. It is a list. Okay. A list is sort of the fundamental non-atomic vector, and it is what we're going to be talking about all in the next set of videos. So this is a list. This is not an atomic vector. And so an empty value in a list is called null. Okay. And that's the missing value for non-atomic data. Okay. And this is where we will stop. Next time, we'll pick up with lesson number 7. See you soon.